Alrighty, ladies and gentlemen, we're going to run through some lunar astronomy notes or moon, otherwise known as Luna, the name of our moon. Where did our moon come from? You're going to be watching a video tomorrow about where the Earth came from. Some people think it was struck by another object and broke off from the Earth itself. Others think that the Earth captured the moon in its orbit around the sun at some point, or maybe they formed together at the same time. So there's a few different theories that are out there. You're going to be watching a moon video tomorrow that's going to go through that. Some moon facts here. The moon rises about 45 minutes later each and every day. For example, the moonrise is at 4:48 a.m. on April number 6, and it's going to be at about 5:20 a.m. on April 7th. So each day the moon is going to rise approximately 45 minutes later each and every day. Why does the moon rise at different times of the day? Take a moment in your notes to jot down what your thoughts or ideas are. Why does the moon rise at different times of the day? Pause the video if you need to. Question number 2. We've spent a couple days now going through the different moon phases. So you should be able to answer this question. Why do we see the phases of the moon in the order that we do? What did you do on day number 1? What did you do on day number 2? Why do we see the moon phases in the order that we do? If you need to pause, please do. We talked about the moon phases. You've done a couple different labs about moon phases. As you watch the moon image in the upper right corner, you can see how it waxes from one phase and wanes all the way through the rest of the phases. The 4 main phases of the moon: the new moon, first quarter, a full moon, and the last quarter, sometimes also referred to as third quarter. The moon's orbit is always counterclockwise, just like the Earth rotates counterclockwise. As you see the animation here running, you can see that the moon is orbiting counterclockwise around the Earth. This is as if you were positioned directly above the North Pole. So if you're looking down at the Earth and the moon, you are in a stationary orbit directly above the North Pole. As the moon is traveling around, you can see how the moon becomes illuminated at different points and different amounts with the image on the right compared to where it is in its position on the left. Waxing is the moon getting brighter and more illuminated each and every night. Waning is the moon getting dimmer or less illuminated every night. Or as Mr. Miyagi say in Karate King, wax on, wane off, Daniel-san. Wax on, wane off. For those of you that have seen the Karate Kid original movies, you'll know what I'm talking about. This should look familiar to you folks after doing our moon phases lab. You can see that the waxing crescent is the first stop after the moon has been new. The one key, remember, in looking at all of these diagrams is where is the sun coming from? Because the sun is going to illuminate each of these moon phases as it travels counterclockwise around the Earth. So in order, it is always new moon, then waxing crescent, then first quarter, waxing gibbous, full moon, then waning gibbous, third quarter, and then waning crescent as you arrive back at the new moon. Question number 3, why do we always see the same side of the moon facing us? Why do we always see that same side of the moon facing us? Jot down your answer. Ladies and gentlemen, the moon is the most unique object in the entire solar system. The moon is the only object whose rotation period and revolution period are exactly the same. It's about 29.53 days. The rotation and revolution are exactly the same. They're not even 1 second off, because if they were 1 second off over 1,000 years, that other side of the moon would eventually face the Earth, and that has not happened. So the moon is a very unique celestial object in that it's the only object that has the same rotation and revolution period. Why do solar and lunar eclipses occur? So we've been working on some activities with eclipses. So what did you see? Why do we see a solar eclipse? Why do we see a lunar eclipse? Take a moment and jot down your answer here. Which of these pictures is a solar eclipse? Which of these pictures is a lunar eclipse? You should be able to answer that. You can just write down left picture or right picture, and then you can label which one is a solar eclipse and which one is a lunar eclipse. Remember, when you have an eclipse, it is casting a shadow from one celestial object onto another. So with a solar eclipse, the moon is casting a shadow onto the Earth. With a lunar eclipse, the Earth is casting its shadow onto the moon. So in a solar eclipse, the moon blocks the light to the Earth, and in a lunar eclipse, the Earth blocks the light to the moon. Pause the video if you need to. Here's the diagram of the solar eclipse. You can see the picture of a solar eclipse in the upper right-hand corner. Here we have the sun, now obviously not to scale, and the moon casting its shadow, or the umbra, onto the Earth itself. Whereas we look at a solar eclipse, you might remember the famous eclipse a few years back, August 21st, 2017, where it crossed directly south of us here in Missouri. The blue line represents the totality line, and the red band line actually the red line on each side represents the totality line. The blue line is just simply the center of that. That's where you're going to see the eclipse for the greatest amount of time. When is the next solar eclipse? Ladies and gentlemen, it's just a couple years away, okay? August 8th, 2024, we are going to have another total solar eclipse cross the United States. So you'll have to head south down to Missouri again. It'll actually be arcing all the way from San Antonio, Texas, arcing all the way up through Maine. So you can see this path. Set a reminder on your phone, August 28th, 2024. This is where the next solar eclipse is going to happen in the United States. Total solar eclipse. On this slide here, you can see that, yes, the 2017 and 2024 eclipses did cross. There is a gentleman who has a big sign on his property where both of the eclipses crossed his land. They made an X, one going one direction, one going another direction, separated by 7 years. So when are we going to have a total solar eclipse in Minnesota? Okay, guys, hang on. Here it is. Here it is. Oh, September 14th, 2099. Yep, you heard me right. September 14th, 2099, there will be a total solar eclipse crossing Minneapolis-St. Paul. Wow. This picture here actually shows all of the total solar eclipses in North America over the 21st century. So here's a good question for you. How old will you be on September 14th, 2099? Lunar eclipse. Lunar eclipse, here we see that the Earth is blocking the sunlight to the moon, causing it to be that ambery red color. If you've ever seen a lunar eclipse, the reddish color, it almost looks very Mars-like as that is happening. So here we have a lunar eclipse. Why don't we have a lunar eclipse every single month? Because the Earth passes in front of the sun and the moon every single month. Why don't we have a lunar eclipse every month? Well, the answer is because the moon is tilted 5 degrees in its orbit. So instead of being on the plane of the solar system, like the Earth and the rest of the planets are, the moon is actually tilted, and it's tilted 5 degrees off of that. So sometimes the moon is above the plane, sometimes the moon is below the plane. An eclipse can only happen when the moon is actually on the same plane as the sun and the Earth. That's when you're going to have a total eclipse occur. The moon's orbit, just to see that, sometimes the shadow is going to cast a shadow off into space, or it's going to cast a shadow above or below the Earth. So that 5-degree tilt really does make up a difference as to why we don't have a lunar eclipse each and every month. We'll talk about the tides. High and low tides, it's caused by the gravitational pull of the moon. The moon's gravitational pull is because it's creating what's called a tidal force, and it's actually pulling on the water of and the oceans of the Earth much more than the sun does. You've watched a couple video clips on that and explained as to why that is. So we have two different types of tides. Well, actually, we'll watch the first little video clip here talking about and showing you how the tides go high and low over the course of 24 hours. You'll also see in the diagram how the moon is revolving and going in its orbit and how that changes those tidal times slightly as time goes on. Spring tides occur when the moon is full or new. Spring tides are creating higher tides than normal, and this was actually used just a few weeks ago when that huge container ship got stuck sideways in the Suez Canal over in Egypt. They had to wait for a spring tide, which is a higher than normal high tide, in order to get that ship to be floated again and not run aground like it had. So spring tides occur when it is new or full for the moon. Neap tides are a lower type of tide, and it occurs when the moon is first or last quarter and the gravitational force of the sun and the moon are perpendicular. So they're kind of canceling each other out a little bit. But what ends up happening is the tides are not very high and the tides are not very low. It's when the water of the oceans tends to be a little bit more consistent or stable. Alrighty, quick pop quiz here, folks. What moon phase is this? Second one, what moon phase is this? Third one, what moon phase is this? Here we go, question number 4, what moon phase is this? Question number 5, which one is this? Question number 6, which one is this? Question number 7, which one is this? Okay, and then I have one final question for, oh, sorry, question number 8, there we go. What's this one? All righty, and then I have one final question for you, ladies and gentlemen. How heavy is the moon? How heavy is the moon? The answer is, it's only heavy enough to be held by a wheelbarrow. There you go. Thanks, folks.